Hello and welcome to Programming with Dave. In this video, I'm going to be working on starting to create an virtual pipe organ application in Python using a few libraries from the Python package index for the execution speed. I will be making use of the UV package manager to manage those dependencies as well as the Python version on my system. And I will also be making use of the Z editor as my IDE environment for the development process. So let me go ahead and bring you to my main screen here with Z already open. Okay, so as you can see, I have an empty project here with an untitled uh, file. I'm just going to close that off. I'm going to click here on Open Project, and then I'm going to click on my name there, go over to Projects. I'm going to create a new project here. I'm going to name this Pi Organ. Click OK, and now I'm going to open it. So I don't know why this happened. So let me go ahead and close the project, and then I'm going to reopen it because I want to be in that actual project directory. There we go, that's better. So this is an empty Pi organ project right now. So the next thing I want to do is initialize it using the UV package manager. So I'm going to just type in UV init and give the package flag. And here we go. We now have just created our PyOrgan package. And now I'm going to go ahead and both add third-party packages from the Python package index, as well as create the virtual environment all at the same time. So to do that, all I have to do is type in UV add, and now our packages, which will be sound device. So we have the ability to play sound through our speakers, NumPy for generating the sine waves. I'm going to use Mido, which is a wrapper around the RT MIDI library in C++. And then we're going to also use PySide6, which is the Qt6 for Python implementation. And as you can see, it's created our virtual environment, added a UV lock file, which contains all the package information needed, and all the wheels, etc. So there we have our actual package initialized. And then one last thing just to clean things up is to have an empty init.py file here. That's just because my main executable for this will actually be a main.py file, which I'm creating here. Uh, so in regards to Python, it can be used as a scripting language, even though it is considered to be a general purpose programming language. And I find, even though I do like having object-oriented structure, using classes, also use some functional programming techniques as well, a good starting point is to create a working script that actually does some work and then expanding the application from there. So my first order of business will actually be to import both the NumPy and the sound device modules into this file. So I'm going to import NumPy as NP and then import sound device as SD. And now we're going to create the actual waveform. Uh, so the waveform equation is wave at time is equal to the amplitude multiplied by the sine of 2 times pi times the frequency divided by the sample rate multiplied by the time, and then uh, one thing that's not going to be implemented now, but will be implemented in the future is adding the phase to that as well. So with that being said, uh, let's start from left and work to right within this equation here. So we're going to need an amplitude, which will be of type float, and we're going to set it equal to 0.5 to start. We're going to take a frequency, which will be a float, and make that equal to 440.0, which is A4, by the way, if you're not musically inclined at all. Next thing we're going to look at is the sample rate, and we're going to make that an integer, and it's going to be equal to 44,100. Yes, there are other sample rates we could use, but I'm just keeping it simple for the purpose of this script. So now the time, I'm going to have that equal to 2, well, it's going to be, it can be an int or a float, but I'm going to make that 2 seconds. So in regards to that time phase thing here that we have going on, I'm going to create what's going to be known as indices, and that's going to be of type ND array, which comes from the NumPy library. Oh, and I do notice that we have an error here. So it's could not resolve imported module. Let me fix that by making sure that we're sourcing our virtual environments. And there we go. That takes care of that problem. So the indices, we're going to be using a range for this. And we're simply going to multiply the sample rate by the time that we've given to give us our indices, which now allows us to actually create the waveform now, which is going to be a NumPy array. So now we just fill everything out. So we go amplitude multiply np.sine, which gives us our sine function. And then we go 2 times np.pi times the frequency divided by the sample rate multiplied by our indices. Okay. And then so now we have the actual waveform created. Now we can actually send that information over the speakers by using the play function, which we're just going to supply with waveform. And then we have sd.wait, which tells the system to wait for that waveform to play through. And then sd.stop to stop the sound device. Now, if I go to my terminal down here to run this file, I just simply type in uv run and then give the exact path to this file, which is src pi organ main.py. And I hope you were able to hear that. That was a 2-second burst at 440 hertz with an amplitude of 0.5, which was quite loud. So we could play with the amplitude to quiet down the sound. We could even make it louder if we wanted to. So we can play with these variables as we like to alter the waveform. So we know that we can actually play sound using Python, which is quite cool. So I think what we're going to do next is separate this script into different parts. This will be in the next video. And then see what we need to do to be able to create more of these waveforms so we can actually add them together to uh, alter the waveform uh, so we can create more complex waveforms. And that's how we're going to be able to create the unique sound of the organ pipes themselves, being able to add the different waveforms together and modify things like the amplitudes and the frequencies in order to get the exact right sound for this specific organ stop. If you've enjoyed this video, you've learned something, and you would like to see more, please like the video, subscribe to the channel, and I'll see you in the next video.